Same stuff we did Thursday, which is a little trickier. Okay, so let's go ahead and look at 8.3 and 8.4. 8.3 and 8.4 are basically the same thing, so I just kind of combined them into one. They're the same thing, basically. I thought it was kind of stupid that they did two separate lessons, but it's okay. So what we're looking at is we are multiplying polynomials. So let's look at these examples down here. We're not going to do them, but let's look at them. So look at example 1. What is different about those examples than what we did on Thursday? So what's different about these two examples than what we did on Thursday for 8.2? So go back and look at 8.2. Look at some examples we did in 8.2. So what's going to be the difference between 8.2 and today? So look at examples, see if you can notice kind of the difference we're going to be seeing. Yes?
You don't have anything in the middle.
What do you mean?
Like in the middle of the
Okay, a little more specific, maybe. What do you mean that you don't have something in the middle?
Like an addition sign?
Okay, so we're multiplying, so make sure you're looking at 8.2 instead of 8.1. It's 8.2. Yeah, 8.2. Okay, so look at 8.2, look at 8.3, 8.4. What do you notice? We're multiplying, so some of it's going to be the same. What's the difference between 8.2 and 8.3 and 8.4? So be looking at examples and see if you can spot the differences. You should be able to notice if you look at some examples. Sorry. Yes?
You're not adding the two together, the two parentheses, and...
I wasn't adding the two parentheses in 8.2. I don't think so. No. No.
You're not true.
Okay, look at 8.2. Look at these examples for 8.2. Look at these examples for 8.2. Okay, I see what you're saying. We had somewhere we had to combine. But let's look at this example 1. This is 8.2. What's different about this example 1 than what it looks like for 8.3 and 8.4? Kinsley?
There's
No
no exponents.
exponents, okay. Keep coming up with some more.
There's
Yes.
2 sets of parentheses.
For what section? In 8.3, 8.4, or 8.2? Which one has the two parentheses? Look at 8.2. Are there two parentheses? The other one, okay? So Caleb says there's two parentheses for 8.3 and 8.4 as compared to 8.2. Okay. Do what?
There's no variable on one side.
Okay. Let's put it into use math words that we talked about. In 8.2, you're all kind of on the right track. You're noticing what things am I multiplying together in 8.2? What types of polynomials am I multiplying in 8.2 as compared to 8.3 and 8.4? So look at the 8.2 notes. What types of polynomials am I multiplying compared to 8.3 and 8.4? You can look at the heading if you need to. Do what? By what? So look at 8.2. Everyone look at 8.2. I explained this Thursday. Some of you guys don't pay attention super well on the notes, and it shows on the homework. When I look at 8.2, what am I multiplying together in 8.2? Use the words. We've talked about how to describe polynomials. So as I look at 8.2, look at this example. I'm multiplying what type of polynomial times what type of polynomial? Nope. We describe polynomials. You can look on the backboard. Some of you guys didn't write down the notes for 8.1. You don't have to worry about the degree. Look at your number of terms. In 8.2, I'm multiplying a what by a what? A what?
The M word.
Monomial. So look, in 8.2, whatever I had in front is a monomial. I had one thing in front. Monomial. 5a squared is a monomial. I'm taking that monomial and multiplying it by a what? What's this in here? Classify this. What's this? Huh? How many terms does this have? Trinomial. So I was taking a monomial times a trinomial. Okay? In this case, I was taking a monomial times There's 4 terms, so that was just a polynomial of 4 terms. So 8-2, I was taking a monomial times something. So that's why we distributed. 1 term times 3, 1 term times 4. We distributed. Now, Destiny, do you have a pronoun? It looks like it. Okay, you're messing with me, sure. So now if I look at 8-3 and 8-4, what am I multiplying together in 8-3 and 8-4? Let's look at example 1. What am I multiplying together? What types of monomials am I or what types of polynomials am I multiplying together for 8-3 and 8-4? Okay, let's look. We have a binomial. 3m plus 4 is a binomial times a what? Some of you guys aren't paying attention. n plus 5 is a what? How many terms does it have? 2. So it's a what? So I'm multiplying a what by a what? Binomial times a binomial. Now we'll get to some harder examples where I'm going to be multiplying a binomial times a trinomial or a binomial times a polynomial of 4 terms. So the difference is we are not just multiplying by a single term. We cannot just think about distributing because I don't just have a 3m out front. I have a 3m plus 4. So that is the difference. Some of the things are going to be the same, but the big difference is it's not just going to be distributing because I'm not just multiplying by a monomial. Here are some steps. We're going to multiply each term. So multiply each term in the first parentheses by every term in the second parentheses. Now, I just got done saying this isn't distributing, but you can kind of use the same idea, except it's going to be a little more complicated. So you're going to take each term in the first parentheses and make sure you multiply it by every term in the second parentheses. The next thing is to combine like terms, which we've done before. If I have x squares, put them together. If I have x cubes, put them together. Combine like terms and simplify. So these are the steps. So it's kind of the same idea as distributing, except you have to do it twice. So as I look at example 1a, you're going to take every term in the first parenthesis and multiply it by every term in the second parenthesis. So we're going to start with 3m. Start with your first term. We're going to multiply that by the 2 terms in the second parenthesis. So we're kind of distributing, except we're going to have to do it twice. So take each term in the first. So I'm going to start with 3m, and I'm going to distribute it to every term in the second parenthesis. Yes?
Would you have exponents of these?
You will, yes. Because what's 3m times m?
M2 squared.
Yeah. So 3m squared, 3m to the second. And what's 3m times 5? 15m. Okay? So it's kind of the same idea with distributing, except we have to do it 2 times. Now am I done here?
No.
No, because I have that 4. So now I take the 4 and I distribute it. So we're kind of distributing twice. What is 4 times m? 4m. Now, like I showed you last week on one of the warm-ups, if it is helpful for you to look to see like terms and put it right underneath it, instead of just writing it at the end, it doesn't really matter if you want to do the horizontal method instead or the vertical method instead of just keep on going down the row. And then what's 4 times 5? 20. And there's no just constant to put the 20 under, so you just put it by itself. So if it's helpful for you to do the vertical method and put it right underneath it, that is fine. Now, the second step, combine like terms. So what things can I combine here? 15 and the 4, they both have an m. So as I write my final answer, I'm going to have 3m squared plus what? 19m plus 20. And that's my answer. So same sort of idea, except you're going to have to do it multiple times. Okay, this is one way to do this. I'm going to show you another way that you're going to see in Algebra 2 and stuff, but this is one way to do this. Okay, let's look at the next one. Try B real quick on your own. So try B on your own real quick. Same idea. Take every term in your first parenthesis and distribute it. kind of like double distributing. If you want to think of it that way. It's a good time. If you're confused on this, get an answer now before you have to worry about it on the homework. Yep. Okay, someone go do this on the smart board real quick, please. Brian, you got it? So as you're looking at this, you need to look at it and say, okay, it's a binomial times a binomial. So I don't just take something and distribute it. I have to take two things and distribute it.
And is this work?
Yeah, that's fine. Just grab a pen or write it down. Check your sign. Negative 40y, and that's a positive 2y.
Oh.
What?
Yeah, you were touching it with your wrist, I think. I know, sorry. Okay, so when I take the first two, 5y times a y is 5y squared. And then 5y times your 8, because you distribute your 5y first, is 40y. Now take your negative 2 and distribute it. So negative 2 times y is negative 2y, and then negative 2 times 8 is, yeah, we'll do plus and minus, nice save, negative 16. So go through, distribute it twice, and then you just add down. If you want to put it vertical like you did, you can just add down then. If you want to put it at the end, it doesn't really matter. I'm just showing you kind of vertical or horizontal method, whichever way you want to do. So once you combine like terms, you're going to end up with 5y squared plus 38y.
When I do a plus or minus?
No, just do minus. Minus 16. Okay, if we can read that. So it should say, it's hard to read, that's okay. So it says 5y squared plus 38, that mess in the middle is 38y. So 5y squared plus 38y minus 16. So it's the same sort of idea we did with 8-2, except you're going to have to do it more than once. Okay, any questions on that? So that's one way to do it. If you're good with this way, then you can use this way to do it. Let me show you kind of another way that you're going to see. Okay, this is called foiling. Now, this you might have seen before. If this confuses you, do exactly like we just did. So the nice thing about this is if what we just did makes sense to you, you can just use that thought process and you'll get the right answer. But I want to introduce this to you because you're going to see this in geometry and algebra 2. So if your teachers refer to foiling, then they'll know what you mean. So if I look at a special case, we can only use this when we are multiplying a binomial by a binomial. All this is a fancy way of distributing, basically like we just did. But I want to put the word with it. I want to put FOIL with it. So if you hear that term, you know what I mean. You know what the teacher means. So this is how I multiply a binomial times a binomial. We use FOIL, F-O-I-L, in case you didn't know how to use FOIL. And foiling tells you what things to multiply together. So you're going to multiply your first terms together. You're going to multiply your outside terms together. You're going to multiply your inside terms together. And you're going to multiply your last terms together. Now you can only use this strategy if I am doing a binomial times a binomial. And if this strategy confuses you, just do like we did in the first example. Just use the distributing method. This is just another way to think about it, whichever way is easiest. I want to show you both ways so you can kind of use whichever way is easiest. Okay. Any questions on that? Okay, let's go down. Everyone have this written down? We're going to look at example D. I want to do kind of a harder example with you. Look at example D down here. Now, you have to look at it and you say, okay, obviously I have a binomial times a binomial. I have two terms times two terms. So I'm thinking to myself, I can either distribute it like I just did, or we can use the FOIL method. So the FOIL method says you multiply first your first terms together. So if I look at my parentheses, what are the first two terms in each of those parentheses? 8W and 5W. So what is 8W times 5W? 40W squared. So that is multiplying the first two terms together. 8W times 5W. Now I'll go through FOIL. I multiplied the first two together. Now I'm going to multiply my outside two. So if I look at my parentheses, what terms are on the outside of those parentheses? Do I?
Wait, outside of the
Not outside of the parentheses, but if I look at my parentheses, what terms are on the outside
4
and the parentheses?
6.
Outside. So if I look at all four of them in a row, which two are on the outside? 8W and the negative 6x. So if I look at 8W and negative 6x, so what is 8W times negative 6x? Negative what?
Negative
48.
What?
4.
Negative 48. What? WX. Okay? So that's my outside two. We're on 8. We're in 8.3 and 8.4. Now my inside two. As I look at my four terms in a row, what two terms are my inside two? 4x times 5w. What is 4x times 5w? 20xw. And then the FOIL, I multiply my last two together. So if I look at my last two, that's going to be what? What are the last two in those parentheses?
4 and 6.
4x times 6x. What's 4x times 6x? Negative 24x squared. If you notice, all we did was distributing. Foiling is just a fancy way of distributing. So if the foiling confuses you, don't think about it, but I at least wanted to tell you about it so when you get to Geometry Algebra 2 and they say FOIL, you know what they mean. All this is distributing. Do not make this harder than it is. All we did was distributing. So as I look at this, the second part is to combine and simplify. So what terms can I combine here?
40w squared and 44x.
We have to have the exact same variable and exponents.
Then 48, 20.
48 and 20. Even though they're switched, the w and x are switched, doesn't matter. So I'm going to have 40w squared. If I combine negative 48wx and 20xw, I'm going to have what? Just wx. I'm adding them, so I don't do anything with the exponents. If I was multiplying, I would, but I'm adding. So it's just negative 28wx. You could put xw, doesn't matter the order. And then minus 24x squared. And there is your answer. Okay? Same idea. Do not get confused with the FOIL. FOIL is just distributing like we did in example 1. It's the same thing, just a fancy way to put it. Okay? Let's look at one more examples of these. Let's look at E real quick. Now you look at E, your first thoughts are what? When you look at E, because you're going to get some like this, and if you see this on the test or you see this on your homework, what is your first thought? Distribute the exponent. 8c squared plus 3d squared. You cannot do that. So you need to get past the idea of distributing that exponent. I cannot distribute that exponent. I can't take 8c squared and then 3d squared because that plus in the middle. So how can I rewrite this? Michelle, keep your head up, please. How can I rewrite this? How can I rewrite something squared? We've talked about this before. Something squared is just what? Multiplied by itself. So I can just rewrite 8c plus 3d as multiplied by itself. So I'm going to have 8c plus 3d times 8c plus 3d. That is what squaring it actually means. Multiply it by itself. You know that. Do not distribute the exponent. I see this every year. You have to write it as multiplied by itself. Now you notice that this is a binomial times a binomial. So I can FOIL it or just distribute it. It's basically what FOILing is. So as I go through and FOIL this, What's going to be the first things I multiply together?
The 8 and 8.
8c and 8c. So what is 8c times 8c? 64c squared. All we're doing, if FOILing confuses you, just think I'm taking everything in the first term and distributing it. The next one, if I FOIL, I multiply my outside 2. If I think distributing, that will be what? 8c times 3d. So 8c times 3d is 24cd. Good. 3d times 8c, the inside 2, 24cd. Or dc, it doesn't matter the order you put them because it's multiplication. And then my last two, 3d times 3d, 90 squared. So it's a binomial times a binomial, so we just FOIL that. So as I go through, combine my like terms, which two can I put together? So 64c squared plus 48cd plus 90 squared. Good. And that is your answer. So I put way more examples on there than I needed, but that's okay. Okay, any questions on that? Okay, let's look at some story problems. There will be some on the homework, so make sure you're asking questions on these if they don't make sense. Example 3. A contractor is building a deck around a rectangular swimming pool. The pool has a length of 20 feet and a width of 15 feet. The deck is X feet from every side of the pool. I want to write an expression for the total area of the pool and deck. It is a story problem, so what is the first thing do I look for every time? What is the first thing I look for every time I have a story problem? What are they asking for? So as I read this, or what they're trying to find, same thing, what are they asking for in this story problem? What do they want? I want to write a what? Read it. Write an expression. So write an expression for the total area of the pool and the deck. So I'm going to be looking for area. That's what they want. I want an expression. Now it doesn't say what is the area, so I'm not actually going to be finding the area. I'm getting an expression. So I'm going to have variables, exponents, numbers, add, subtract. That's an expression. Okay? Now as I look at this, let's draw a picture. So you can use this space up here, draw a picture. So as I draw a picture, tell me things from as you read this, that will help you draw a picture. Rectangle. Okay, good. Rectangle swimming pool. Okay, keep telling me some other things that you could put on the picture. Length is 20. Doesn't really matter which side you pick. I usually pick length as the horizontal, the bottom one. It doesn't really matter on a rectangle. So length is 20. What else do they tell me? Width is 15. As you keep reading, now this is kind of the tricky part. What do they tell me about the deck? Because I want the total area of the pool and the deck. Is more, keep reading it. The deck is what? Okay, so as I'm drawing my picture, if my deck is X feet from every side of the pool, what does that mean, picture-wise? If it says my deck is X feet from every side of the pool, it surrounds it. So if I draw my picture, we can draw from every side something like this. So if I draw my deck, this is my deck. It's X feet. I know, look at me go. So it's X feet from every side of the pool. So that deck surrounds the pool, which makes sense because you know what a deck around a pool looks like. And it is X feet from every side of the pool. Questions on that? Now, I want the area of the pool and the deck. So if I think about my area formula, what formula will I start with? What shape is this? A rectangle. So what is, length times width. So I'm going to start with length times width. We can use parentheses. That might be easier. Length times width. We don't really use dots anymore. Now, I want the area of the pool and the deck. So what will be the length of the pool and the deck? Okay, start with 20, because that's the length of the pool. I want the pool and the deck. So what will I add to 20 to give me the length of the pool and the deck? Close. 2x. Now why is it 2x? Look at your picture. Why is it 2x and not just x? Do it both sides. Yep. So I'm going to have 20 plus x on the right plus x on the left. So 20 plus 2x is the length of the pool and the deck. What will the width of the pool and the deck be? 15 plus 2x. Any questions on how I got that? Now, if I want to simplify this, this is a binomial times a binomial. I just distribute or FOIL it. So start with 20 times 15. What's 20 times 15? Have a calculator. If you don't have one, go grab one. Always do that before notes. Just go grab a calculator because I want you actually doing this, not just sitting there zoning out. 20 times 15. 300. That's fine, I don't care. 300. That's when I did the first two multiplied together. 20 times 15. 300. Okay, what are the next two I'm going to multiply together? 20 times 2x, which is 40x, so plus 40x. You guys can do this. You seem to be getting it. Now, if I think about FOILing, or if you're just thinking about distributing, what's going to be the next ones? 2x times 15, my inside term. So that's 30x. And then my last two. Times 2x, which is what? 4x squared. So there's my expression. It doesn't say what is the area. It says write an expression to represent the area. So simplify this. What things can I combine here? So that's going to be 300 plus 70x plus 4x squared. Now, even though I don't have a number, we still want to label this. This is the area. So area is always what? Not necessarily feet, but area is always squared. This is feet, so it's going to be feet squared. You're fine. So just label it, even though I don't have a number, still label it as feet squared, because it represents a number. Okay? Any questions on that? Okay, we're going to skip the second part for right now. Let's look at the next story problem. You guys can do these. There's going to be some of the homework similar to this. That's why we do them in the notes. Okay, let's look at B. A patio in the shape of a triangle with height x minus 7 and base length 6x plus 4 is being built. I spelled that, spell check. Is being built in Lavallease. They choose the weirdest names in this book or whatever. The dimensions given are in feet. The area of the triangle is 1/2 the height times the base. You know that. 1/2 base times the height. Write an expression for the area of the patio. So it is a story problem. Read what they know. What do they want to know in this story problem? What are they looking for? The area of the patio. Write an expression. So we're not going to get a number answer. We're going to get an expression like we did in the example before. Write an expression to represent the area of the patio. How do I get started with this? Yep. They tell me the patio is a triangle, and then they actually tell me the area formula. 1/2 height times the base, or base times height, which is usually how I see it. Start with the formula. If they don't give you one, we know I'm looking for the area of a triangle, because the patio is a triangle. So there's my formula. Start with that. Start with what you know. Now as I go through, we can draw a picture real quick. Here's my triangle, my patio. I have a height, x minus 7. So how do I represent the height of a triangle?
From the top point, you go straight up.
Like that. Yep. So that is x minus 7. That is the height. And I have a base length of 6x plus 4. So where's the base? Yeah, 6x plus 4. That whole bottom part is my base. So if you want to draw a picture, you can. They might give you a picture. Just depends. So as I write this formula, it's going to be 1/2 times my base. So what goes in for my base?
6x plus 4.
Yeah. My height, what goes in for my height? Yeah. Now I want to simplify this, so I notice I have that 1/2 out front, and then I have a binomial times a binomial. So what can I do first before I worry about foiling or distributing? Well, we are distributing, but what can I do first?
Multiply 6 times 1/2 and just get 3x.
Yep, take that 1/2 and multiply by the 6x plus 4 part. So we are distributing. So what's 1/2 times 6x? And what's 1/2 times 4 plus 2? So you can take the 1/2 and distribute it through first. Just kind of lose the 1/2. It's easier to see now. So I have 3x plus 2 times x minus 7. It's a binomial times a binomial, so we can just FOIL or think about distributing. So the first two I'm going to multiply together is going to be what?
3x times x.
So 3x times x? 3x squared. Next two? 3x times negative 7.
Negative 21.
Perfect. Negative 21x. Don't forget the negative with it. My inside, if I start distributing my 2x. And then 2 times negative 7. So there's my expression. Yep. So make sure we have that down. We'll talk about how to simplify in a second. So now as I look at simplifying this, what can I combine?
21 and 2.
Yep. So 3x squared was negative 21x plus 2x. Negative 19x minus the 14 at the end. No, you're good. So there's your answer. You guys can do this. Okay, the nice thing about this class is we can take our time. So if you're like, this stuff is easy, that's fine. I'd much rather you think it's easy than think it's hard and have to rush through it. Okay, 2 more examples. It's done the same way. You can do this. Now, let's look at example 4. As I look at example 4, I want to find each product. Product is multiplication, so I'm multiplying these. Now, what is different? If I look at A, what is different about example 4A than the ones we've done previously in this section? They have an exponent there, okay? It's a trinomial. So I have a binomial times a trinomial instead of a binomial times a binomial. We can't FOIL, but we're just going to distribute like normal. If FOILing confuses you, don't think about it. But all we're going to do is the same thing we did with the binomial. We're going to take everything. It is the same strategy. Take everything in your first parenthesis, every term, and distribute it through every term in your second parenthesis. It's going to look complicated because there's going to be lots of crap and lots of terms happening in here, but you can do it. So we're going to take 6x times 2x squared. So what is 6x times 2x squared? 12x to the third. It's distributing, just lots of times. 6x times negative 3x. Yeah, negative 18x, 6x times negative 3x will be squared. Good. And then 6x times negative 5. Negative 30x. So we're distributing. You just have to do it lots of times. Any questions on that? Is that my answer? No, I have to take my 5. You have to take every term in your first parenthesis and distribute it, or multiply it by every term in your second. So now we're going to take the positive 5 and distribute it through the second parenthesis. Now, this is where the vertical method gets really, really handy because you have lots of terms to keep track of. So what is 5x times 2x squared? 10x squared. So I'm going to put it right underneath the negative 18x squared. So this is where that vertical method gets really handy. If you still want to just put it all at the end, if that's easier for you, I don't care. But the vertical method is nice for this because you have lots of stuff to keep track of. 5x times negative 3x. negative 15x, so I'm going to put it underneath the negative 30x.
There's no x behind the 5.
Do I?
You keep saying 5x.
Oh, am I? Sorry. 5 times negative 3x. Sorry. 5 times negative 5.
25.
Negative, don't forget negatives, negative 25. There's no other constant there, so it's just a negative 25 by itself. So I like using the vertical method because you can line up. Now, I am adding these two, so don't forget you're adding them together. So you can just add down 12x squared, 12x cubed. How many x squared am I going to have? Negative 8x squared. X's,
15.
they're both negative. So when I add two negatives, nope, add and keep the negative. Negative 45x minus 25, and that's your answer. So the vertical method is helpful for this because you kind of keep track of all your term. Okay, any questions? Okay, we're going to do one more example, the last one, B. You'll be fine. As I look at B real quick, what is different about B than the one we just did? It is a trinomial times a trinomial. You do it the same way. These ones are going to have lots of terms to keep track of. So make sure you go through and you see, okay, I'm taking this first term, distributing, second term, third term. So we're taking each term in my first parenthesis and distributing it. So I'm going to start with my m squared. It's the exact same idea. You're just going to have to distribute again. So I'm going to take every term in the first parenthesis and distribute it. So start with m squared. We're going to go through and multiply it by everything in the second parenthesis. So what is m squared times 4m squared? 4m to the fourth. I am multiplying because that's what distributing is, so I add my exponents. 4m to the fourth. Good. M squared times negative 7m. Negative 7m to the third. You've done this before, it's just you're going to have to distribute more than once. M squared times 5. 5m squared. Sorry, 5m squared. So that's the first term and the first parenthesis being distributed through the second. Any questions so far? Now, what do I need to distribute next? The 2m. So now I take my second term and I distribute my second term through the second parentheses. What is 2m times 4m squared? 8m to the third. So I'm going to put 8m to the third. This is where that vertical method is nice because it kind of lines them up for you. So it saves you time at the end trying to search for what goes together. So 8m to the third, 2m times negative 7m. Negative 14m squared. So I put it underneath the positive 5m squared. The vertical method is very nice for these because there's lots of stuff going on. And then finally, 2m times positive 5. 2m times 5? 10m. There's no other, just m, so I just put it at the end. Am I done? No. What else do I need to distribute? Negative 3. Make sure you take the sign with it. Take your negative 3. Like I said, these ones take a while, but we're just distributing. You can do it. You're just going to have to distribute 3 times. What is negative 3 times 4m squared? Negative 12m squared. So it's m squared, so I'm going to line it up vertically with my other m squared. Negative 3 times negative 7m. Plus 21m, so I line it up with my other m. And then negative 3 times 5. Negative 15. Now I have all my distributing done. So we're going to add all 3 of these together. I like the vertical way for this. It's easier for me to see. So go through. 4m to the fourth. How many m cubes am I going to be left with when I combine? Negative 7 plus 8. Negative 7 plus 8. 1. Two different signs, so you subtract and keep the sign of the bigger number. So positive 1m cubed. Now m squared, there's 3 of them going on. Just do each one. What's 5 plus a negative 14? Negative 9 minus 12, or plus a negative 12.
21.
Negative 21 m squared plus 31m minus 15. I know these ones take a while. I don't give you a ton of these on your homework. I only give you 4, I think. But you can do it. It's just distributing multiple times. Okay? Any questions so far? Doable? Maybe? Maybe? Okay. Homework is going to be, let me write it up here. Okay, homework for today is page 483, 1 through 24. And I want you to do 4, 8, and 12 now. So I want you to, it's 1 through 24 is your homework. There's some odds in there, so I'm expecting you to check them. Now, I need to see work. So you might be able to, you can't really do any of these just in your head. I want to see the work exactly like the notes. If not, especially for the odds, I will not give you any points. If you just have an answer and you didn't go through the foiling or distributing work, I'm not giving you points. Show work exactly like we did in the notes. Yes?
None of those 4, 8, 12, those are not the ones we've been trying out, are they?
There's one on there. Yes. I want to make sure you can do it before you get on the homework. So 1 through 24 is your homework. I want you to do 4, 8, and 12 first. Once you have those done, have us check them. And then we'll